The first one I'll be talking about is heat of neutralization. What is heat of neutralization? In a simple term, or in a simple language, the heat needed for neutralization reaction to take place is what we call heat of neutralization. I hope that is got to now. The big question we are now going to ask ourselves is that, what is neutralization reaction? Are you getting it now? So, neutralization reaction is the reaction between hydrogen ion of an acid and hydroxyl ion of a base to form water. Are you getting it now? So, the heat of neutralization now can simply be defined as the amount of heat evolved when 1 mole of hydrogen ion from an acid reacted with 1 mole of hydroxyl ion from a base to form 1 mole of water. Look at this definition. What is the salient points that examiners will mark in this definition? This is one of them. Amount of heat evolved. 1 mole of hydrogen ion from an acid. Then 1 mole of hydroxyl ion from a base. If WAEC asks you a question like this, and 3 marks is allotted to this question, these are the salient points that will carry 1 mark each. I hope that is clear. Now let me bring out the most important aspect of this definition. I mentioned it evolved. The implication of this is that for any chemical reaction in chemistry, for any reactant particle to react and form the product, it is either there is evolution of heat or absorption of heat. Is that got to now? Evolution of heat means it is either it is going out, moving out from the system, or it is moving into the system. If it is moving out into the system, if it is moving out of the system, such system is said to be exothermic. Any system that loses heat to the surrounding is said to be exothermic. I hope you are getting this. Any system that absorbs heat from the surrounding is said to be endothermic. Now let me quickly digress a little bit. What brings about exothermic and endothermic process? Let's say very early in the morning, before you leave your house, you have 2 cups of the same color. Are you getting it now? There is ice block in cup A. There is boiled water in cup B. This is around 7 a.m. in the morning. You now keep both cups outside your house. You leave the house and you come back around 4 p.m. in the evening. If you look at the contents in both cups, what will you find there? Water, right? So the content of both cups will now be water. Now, what has happened to the ice block? it has gained heat. What has happened to the boiled water? It has lost heat. Are you getting it now? Ice block is able to gain heat from the surrounding because it is colder than the surrounding. Any system that is colder than the surrounding will absorb heat to the surrounding. This is in a bit of this system to establish an equilibrium with the environment. Are you getting it now? Boiled water has lost some heat to the surrounding. Why? Because the temperature of boiled water dropped. The temperature of ice block raised. You know, the temperature of ice block is 0 degrees centigrade. The temperature of boiled water is 100 degrees centigrade. Now that at 4 p.m. you are having liquid water in both cups, that is telling us that what has happened to this is rise in temperature. And what has happened to this is loss in temperature. Are you getting it now? This one loses heat because it is hotter than the surrounding and it has to establish an equilibrium with the surrounding. Are you getting it now? Now, in short, any system that is losing heat to the surrounding system, that process, if it is occurring in a chemical reaction, that reaction is said to be exothermic. Any system that is taking heat or absorbing heat from the surrounding, that system is said to be endothermic. Now, let me clear something very important here. When you are writing WAEC, you have to be very careful when given the definition of different types of heat of reaction. Are you getting it now? I use evolved here because I am pretty sure that whenever hydrogen ion from an acid try to react with hydroxyl ion from a base, it is going to give me H2O. I'm pretty sure that neutralization reaction is an exothermic process. How will you know that? If you have been to a chemistry laboratory before, just take some stock HCl and mix it in NaOH. Initially, the container will be warm. Are you getting it now? That is, the reactant particle are still trying to react. But with time, the reaction will be getting cooler. What that implies is that a neutralization reaction occurs by losing heat to the surrounding. That is why neutralization reaction is an exothermic process. And since we know it is an exothermic process, we are going to use evolved when given the definition of heat of neutralization. Are you getting it now? So another prominent type. Now let me also bring something in here. If there is something we also call standard heat. Standard heat of neutralization. What is the distinction between ordinary heat of neutralization and standard heat of neutralization? If you have to distinguish between this in WAEC or NECO, the only thing you need to do is that repeat everything you've written under ordinary heat of neutralization. Now for the standard heat of neutralization, just add under standard condition. That under standard condition fulfills so many criteria. It fulfills standard condition of temperature, standard condition of pressure, and standard condition of numbers of mole. I hope that is clear now. The second point I will explain today is heat of solution. Heat of solution. heat of solution. Now, how do we define heat of solution? The first thing, what is solution? When we have a solute, when we have a sugar, and we put that sugar inside water, what will the sugar form? We are going to have a sugary water, isn't it? A water that will be tasting like sugar, isn't it? This sugar is known as the solute. This water is known as the solvent. Then the sugary water is known as the solution of sugar. Are you getting it now? If it is salt plus water, it is going to give us what we call brine. Are you getting it now? The meaning of brine in chemistry is salted water. If I asked you to give me a brine as a chemistry student, everything I'm asking you to do is to put some salt inside water for me. Are you getting it now? Now, a certain amount of heat is needed to make sugar dissolve in water, or to make salt dissolve in water. That heat that is needed to make a solute dissolve in a solvent is what we call heat of solution. I hope that is clear now. Now, you define it as the amount of heat evolved or absorbed when 1 mole of a substance dissolves in water. If you look at this definition compared to the earlier definition I gave under heat of neutralization, you can see I mentioned heat evolved or absorbed, meaning that there are some substances that when you dissolve them in water, they will evolve it, they will lose it to the surrounding. And there are some substances that when you dissolve them in water, they will absorb it from the surrounding. Let me give you an example. If you try to dissolve carbide in water, what you are going to experience is a splash of gas. Carbide is what you normally call carbide. Are you getting it now? Are you getting it now? So, you see something splashing out. And if you touch the jar or the bucket you are using to dissolve in it, you will discover that it will become very hot. So the solution of carbide in water is an exothermic process. It loses heat to the surrounding. But if you dissolve sugar in water, you won't feel any heat. Are you getting it now? Or have you tried to dissolve sugar in water before and you see the cylinder getting hot? No. That means the solution of sugar in water is an endothermic process. Now, what is the clear boundary between the two now? For anything to dissolve, 2 types of energies are needed. The first energy is what we call lattice energy. The lattice energy is responsible for breaking down solute particles. Then the other type of energy that is involved is the hydration energy. The hydration energy pumps water into the broken down particles. Now listen, let me give you a very clear illustration that will make you understand it clearly now. How do you now know that a substance, a particular solute that is dissolving is exothermic or endothermic. Whenever the lattice energy is greater than the hydration energy, are you getting it now? That reaction is an endothermic reaction. Is an endothermic reaction. But whenever the hydration energy is greater than the lattice energy, that reaction is an exothermic reaction. Let me give you a practical example. Many of you know cubes of sugar. If you want to dissolve cube of sugar inside water, cube of sugar, you know the shape is square in shape. The first thing you are going to observe is that the first thing that will happen to the sugar is that it will be losing its shape gradually inside water. You will still be seeing white particle breaking down from the sugar. The energy that is responsible for breaking that, please pause. The first thing you are going to observe is that the cube of sugar will be losing its shape, and you will be seeing a white crystalline substance inside the water. What has happened to the sugar is that the lattice energy is trying to break it down first. Then the next thing you are going to observe is that those tiny white particles you are seeing inside water will be disappearing little by little. Are you getting it now? The reason why you are able to see that there are some white crystalline particles inside the water is because the lattice energy that is breaking down the sugar particle is more powerful than the hydration energy that is pumping water into it. Let me give you a practical illustration. Let's say in your house, you and your younger sister, you are washing the plates while your younger sister is rinsing it. Are you getting it now? You that is washing the plate, I'm likening you to the lattice energy. Your sister that is rinsing the plate, I'm likening you to the hydration energy. You know, if you are the one that is faster than your sister, there will be leftover plates that will not have been rinsed. Are you getting it now? But if your sister is faster than you, she will have to be dragging some plates in your hand. Now, for the dissolution of carbide, are you getting it now? You know when you drop carbide inside water, what you see is a splash immediately. Meaning that the hydration energy that wanted to pump water into the carbide is already waiting. They are already enough. They are already greater. They are already in larger quantity than the lattice energy that will break the carbide particle down. Meaning that before the lattice energy could break the carbide particle down, the hydration energy has already started pumping water into it. That is a major reason why in the dissolution of carbide, hydration energy is higher than the lattice energy, and the reaction is exothermic. But in this, lattice energy is greater than the hydration energy, and the reaction is endothermic. In our next class, we are going to treat other types of reactions.